How's it going, everyone? What we're going to talk about today is whether it's possible to take a seemingly obvious, objectively true, factual statement and create a reasonable argument against it. And the example we'll be using is maybe the most obvious, objectively true statement one can think of. 1 plus 1 equals 2. Is this an objective fact, or are there counter-arguments? So, let's form a counter-argument against this. First of all, 1 and 2 are not something that exist in the physical world. They are completely abstract concepts. 1 apple exists. 2 months exists. But 1 on its own, 2 on its own, right? Not one of anything, not 1 apple, not 1 month, but just 1. That's an abstract concept. It's an adjective that can be attached to a real thing. So you get 1 apple, 2 apples, but on its own, it's not real. Now there are adjectives that really exist, like red. Okay? A red apple. Well, red exists in the physical world. It is a range of wavelengths of light. Light is real. It exists in different wavelengths. Some of those wavelengths we call red. But 1 on its own, 2 on its own, abstract concepts. So a statement that is completely abstract, 1 plus 1 equals 2, a statement that does not refer to anything that's in the physical world, how could we call that statement true? If for something to be true, it has to accurately describe some aspect of the physical world, how can a statement that exists outside of the physical world be called true? Well, maybe if it could still be used as a tool to describe the physical world. For example, 1 apple plus 1 apple is 2 apples. 1 month plus another month is 2 months. So if 1 of anything plus another 1 of that thing results in 2 of that thing, well then we can generalize and just say 1 plus 1 equals 2. And in that case, this would be a true statement. So then we ask ourselves, well, is that the case? Is it true that 1 of something plus another 1 of the same thing will give you 2 of that thing? Are there counterexamples? Sure, 1 plus 1 apple plus an apple is 2 apples. Well, what about 1 person plus another person? Okay, you have 1 person, they start living with another person. Do you get 2 people? Well, sure, initially you do, but if it's a male and female, and you wait long enough, you check on them, it could be 3 people, or 4, or 5, or more than that. So we found an example where 1 plus 1 is initially 2, but then it can be 3, 4, 5. How about 1 animal plus another animal? Will you get 2 animals after you check on them? Well, sure. Say it's a mouse that you put in a snake cage. You get 2 animals in that cage, but wait long enough, now it's only 1 animal. So with the right time frame, does that mean 1 plus 1 equals 1? Well, what if it wasn't a mouse dropped in there, but some poisonous insect, and the insect gets eaten, and then the snake dies? And so if you check after a long enough period of time, there's actually no more animals in there. So can 1 plus 1 equal 0 in some contexts? So with these examples, we can say that, yeah, okay, 1 thing combined with another thing of that category could lead to an amount that's not equal to 2, but initially it is equal to 2. So 1 plus 1 equals 2 is sort of true all the time. But what if you have 2 masses, 1 kilogram and another kilogram, and you smash them together? so that they connect. And you weigh this lump that is a result. Will it weigh 2 kilograms? No, it's probably going to be less than 2 kilograms, because in that smashing process, some bits and pieces will fly off. So here you have an example where, from the start, 1 plus 1 is less than 2. So, is it then that 1 plus 1 equals 2 is an approximation? It's not always real, but it's real most of the time, and so we call it an objective, obvious fact. Well, that's not really what an approximation is. Something that's true sometimes, but not always. We don't really call that a universal mathematical certainty. So what's going on? I'll tell you what's going on. If you're feeling confused, like you're not sure, right, does 1 plus 1 equal 2 or not, then you're experiencing a phenomena where a very obvious, clear, objective fact can be taken and doubt can be thrown on it. And it could lead you to doubt something that's so obviously true. Now, you don't want that to happen. I can assure you 1 plus 1 does equal 2. It always equals 2. It never equals anything except for 2. But you can be led to believe otherwise. So, let's clear things up now. 1 and 2 are abstract concepts. They're part of a branch of mathematics called arithmetic, which is used to help us count. It is a tool that we created. And in that tool, by definition, 2 is another way of writing 1 plus 1. It's not a question of science, it's a question of something like linguistics. This is a symbolic language that we invented. And in that symbolic language, you can write 1 plus 1, or you could write this squiggly curve that we call a 2, and it's just 2 ways of writing the exact same abstract concept. The concept of there being 2 of something. So by the rules of arithmetic, it's not about science, it's the rules of a written language and conceptual hieroglyphic language. By the rules of arithmetic, 1 plus 1 is 2. Now where does the science come in? Well, that's a different question. We can then say, okay, can this statement here be used as a model to describe certain physical phenomena? For example, if we have an apple plus another apple, will that give us 2 apples? Well, okay, it looks like the theory holds for this situation. Well, what if we have a person and we put them in a house and we add another person in that house and we feed them and all that, but they can't leave the house? When we go check on them after a period of time, will we see 2 people? Well, if we check on them in a month, yeah, we'll see 2 people. So the theory holds. But if they are a male and female, and if we check on them in a year, maybe we'll see 3 people. Maybe we'll see 4. Maybe we'll see, well, not 4 in a year, although it could happen. So in that situation, the theory holds for a short enough period of time, like a month. It does not hold for a longer period of time, like a year or more, or it may not hold. Same with the snake and the mouse. Okay, put the mouse in the snake cage. You have one animal and another animal, and you check on them in a few seconds. Will there be 2 animals in that cage? Probably. So for a few seconds, that theory that the statement 1 plus 1 equals 2 describes this situation, that theory holds. If you check on them, say, in an hour, well, then you're only going to see 1 animal in there. So your theory does not hold. 1 plus 1 equals 2 is not a good model for that particular situation. It's still a true arithmetic statement. It's just that particular equation does not describe the situation. And that's that. Now what's happening with the two masses that we smashed together? If we have our theory that if you take 1 kilogram and smash it together with another 1 kilogram, you will get 2 kilograms. Okay, let's run the experiment. Smash them together, weigh the result. What do we get as a result? We get 1.8 kilograms. Okay, so our theory does not hold. In the realm of arithmetic, 1 plus 1 still equals 2, but that equation does not describe this particular phenomena. Now, we can then further analyze, for example, considering the law of conservation of mass, we should conclude that, okay, well, if this weighs 1.8 kilograms, it means that there is another 0.2 kilograms somewhere out there. And then that can lead us to investigate what chipped away, how much did it chip away. Maybe it was converted to energy if we have a nuclear reaction happening. So the question is not whether 1 plus 1 equals 2. It certainly does, because that is not a scientific result. That is just how we define arithmetic. The question is, what phenomena are modeled well by that equation and which ones are not? So, how were we led astray? Well, we used cherry-picked, flawed examples. And how were they flawed? Because we used loosely defined terms and we were loosely switching between contexts. For example, are we defining plus as putting two individuals, two items beside each other? Okay. If we're doing that, then how come when we have our male plus our female, that's 1 plus 1? But then if a child is born, shouldn't that be another plus 1? 2 plus 1 equals 3. Well, it looks like the theory holds. 1 plus 1 equals 2. And then we have another process going on where 2 plus 1 equals 3. If combining our animals of a snake and a mouse gives us 2 animals, if that's plus 1, well then when the mouse is eaten, shouldn't that be a minus 1? 2 minus 1 equals 1. Or if we want to draw the whole process, 1 plus 1 minus 1 equals 1. The arithmetic holds. Or for the people having a baby. 1 plus 1 plus another 1 equals 3. It's not 1 plus 1 that equals 3. It's 1 plus 1 plus 1 that equals 3. And that's if plus means combining individuals. But then we switch over and now plus means combining masses. Okay, well, if you were to add the 1 kilogram, the other kilogram, smash them together, you weigh everything in this larger lump here, and then all of the little bits and pieces that fell off, you will get 2 kilograms. If plus means not adding individuals, but adding mass, well then, when the snake eats the mouse, and you weigh that snake, you're still going to have the mass of the two of them combined. And for the 2 people to create a third person, well, those 2 people are going to be eating in that process. And if you add all of that mass together and you don't subtract any of the mass that people lost in the process, you're still going to have conservation of mass. And you're still going to have your arithmetic addition strictly hold if you can manage to weigh everything properly. So with these kind of loose definitions, switching contexts without describing that we're switching contexts, one can really be led astray, and you don't want to fall for that trap. Right? You don't want to be led to believe that something that is an objective fact is actually not true. But it can be done. Reasonable sounding arguments can be created against what seems like such an obvious truth. And we did this with mathematics. We did this with 1 plus 1 equals 2. Mathematics is maybe the most objective field that exists. Everything else is even less concrete than that. So if these tricks can be played with mathematics, they can certainly be played with everything else, with every other seemingly blatant, obvious statement. So what do we conclude? Just because something is objectively true does not mean that reasonable sounding arguments cannot be created contrary to it. And just because those reasonably sounding arguments exist does not mean that the true statement is any less true. You want to look for, are we defining terms clearly? Are we applying contexts clearly? That's what you want to look for. And of course, just because something is factually true in one context doesn't mean that it's a model that works in every single other situation. It all depends on how you define, in our example, your experiment. Right? If your experiment is just smash 2 kilograms together and your theory is that the resulting lump will be exactly equal to the two masses, well, that theory is false. But arithmetically, 1 plus 1 still equals 2. You're just losing some mass somewhere, as an example. So, I hope that helps you understand the world around you. And until next time, enjoy.